If you squeeze the Earth into a cube, how do you think you would die? Would you be crushed into a slab of meat, flung off the planet, or boiled alive? The answer is, all of the above. And they would all happen within 3 minutes. If you were standing on the edge of a cubic Earth, gravity would pin you sideways against the wall. Your bones would shatter, your organs would rupture. If you were standing on one of the corners, you would be flung straight into space, without even a chance to scream. Even more terrifying, the entire planet would begin to destroy itself violently. The surface temperature would soar to 10,000 degrees. The oceans would evaporate completely within 10 seconds. All mountain ranges would melt like ice cream. In the end, this cubic Earth would be forcibly squeezed back into a sphere, by a mysterious force. Every object in the universe larger than 500 kilometers cannot escape this fate. But here comes the question. What is this force that can knead entire planets at will? Why does it insist on turning everything into a sphere? The answer is just 2 words, gravity. But that answer is too boring. So let me explain it in a different way. Imagine this. You have just become a newborn planet. Inside your body are trillions of tons of rock and dust, all frantically squeezing toward your center. What does that feel like? It's like a trillion hands pressing you inward from every direction at once. And the force from all those hands is exactly the same. Up, down, left, right, front, back, all equal. When pressure is applied evenly from every direction, what shape can possibly form? There is only one answer, a sphere. That's why soap bubbles are round. That's why water droplets are round. That's why the bubble gum you blow is round. The universe uses the same principle to shape every planet. But here's a deeply unsettling question. If gravity is so powerful, why do some asteroids look like potatoes? And some even look like dog bones? Does gravity not work on them? No. It's because they are too small, so small that gravity can't be bothered with them. The universe has a cruel hidden rule. For objects with diameters smaller than 500 kilometers, gravity is simply too weak to reshape solid rock. So these little bodies can keep their bizarre shapes, looking however they please. But the moment you dare to grow, the moment your diameter crosses that 500-kilometer red line, gravity immediately switches on. Like an obsessive-compulsive perfectionist, it smooths out every bump and every edge on your body. How violent is this process? Let me do the math for you. When an object becomes massive enough, the pressure inside it drives temperatures up to thousands of degrees. At those temperatures, rock melts like chocolate. Steel flows like butter. Even diamonds, the hardest substance on Earth, would be crushed into powder in an instant. All matter turns into a boiling ocean of magma. And under gravity, it obediently flows toward the lowest point. What is the lowest point? The place closest to the center. When everything desperately squeezes inward, a spherical shape forms naturally. This state has a very fancy name, hydrostatic equilibrium. Translated into plain language, gravity has beaten you into submission, and you no longer dare to have any sharp edges. But do you think being round is the final form? That's far too naive. The universe always has ways to blow your mind. Do you know Saturn? Saturn is the flattest planet in the solar system. Its equatorial diameter is a full 10% larger than its polar diameter. In other words, if Saturn were a person, he would be a severely overweight, greasy middle-aged man, with a belly wider than his shoulders. Why is that? Because Saturn spins insanely fast. A day on Saturn lasts only 10 hours. Imagine a behemoth 745 times the volume of Earth, completing a full rotation in less than half a day. That speed generates enormous centrifugal force, flinging Saturn's equator outward. It's like swinging a bag full of water. The middle bulges outward. So strictly speaking, Saturn isn't a perfect sphere. It's an oblate spheroid. Earth is also slightly flattened, just far less obvious. Earth's equatorial diameter is 43 kilometers longer than its polar diameter. If you stand on the equator, you are actually farther from Earth's center than if you stood at the North Pole. Now let me tell you something even more terrifying. What happens if gravity becomes strong enough? Strong to an absolutely insane degree? The answer is, neutron stars. Neutron stars are among the most horrifying objects in the universe. They are only about 20 kilometers in diameter, yet they contain more mass than the Sun. A matchbox-sized piece of neutron star material would weigh over 3 billion tons. What does 3 billion tons mean? It's like compressing Mount Everest into a single sugar cube. Under such horrifying density, how strong is the gravity of a neutron star? 200 billion times stronger than Earth's. On a neutron star, you cannot stand up. You would be flattened into a sheet instantly. Then that sheet would be crushed into a line. Then that line would collapse into a point. The entire process taking less than 0.00001 seconds. Even more absurdly, the surface of a neutron star is almost perfectly smooth. Its tallest mountains are less than 1 millimeter high. Yes, you heard that right. 1 millimeter. Because any material that dares to protrude is instantly crushed flat by the overwhelming gravity. This is gravity in its ultimate form. Not only does it force you into a sphere, it forces you into a flawless sphere with no imperfections at all. But now another question arises. If gravity loves spheres so much, why is the Milky Way flat? Why are Saturn's rings flat? Why does the entire solar system look like a pancake? Has gravity picked favorites? No. There's another physical law causing trouble here. It's called conservation of angular momentum. It sounds complicated, but the idea is simple. Have you ever watched figure skating? When a skater extends their arms, they spin slowly. When they pull their arms in, they spin faster. That's conservation of angular momentum. When galaxies form, gas and dust scattered throughout space begin to collapse under gravity. As they collapse, they also rotate. Motion in the vertical direction cancels out through collisions, but horizontal rotation is preserved. As a result, everything gets flung into the same plane, forming a flat disk. That's how the Milky Way formed. That's how the solar system formed. So the universe isn't stuck playing with just one shape. When gravity meets rotation, it compromises. Flat galaxies and round planets are simply two expressions of the same physical laws. At this point, you might feel that the universe is fairly orderly, that everything is under gravity's control, but I want to tell you about a bizarre discovery. Scientists have observed countless planets and found a phenomenon that remains unexplained. The vast majority of planets in the universe rotate counterclockwise. Venus is the only exception. It rotates clockwise. Why? No one knows. It's like a group of people all agreeing to walk left, except for one person who stubbornly walks right, and refuses to explain why. What did Venus experience? Was it struck by something, or was it always a rebel of the universe? This mystery remains unsolved. Now let's return to the original question. If you somehow managed to create a square planet, what would happen? The answer is, it could exist, but only for a few minutes. During those minutes, it would endure hellish self-destruction. Its edges would be torn apart by gravity. Its matter would melt under extreme heat. The entire planet would violently reshape itself through massive quakes. In the end, it would become a sphere, just like the trillions of other planets in the universe. Gravity allows no exceptions. The laws of physics accept no rebellion. But this leads to an even deeper question. Where does gravity come from? Why did the universe choose this rule in the first place? What would the universe look like without gravity? Would there be square suns, triangular earths, star-shaped moons? Could such a universe give birth to life? Could it give birth to us? Perhaps it is precisely because gravity forces everything into spheres, that planets can orbit stably, that stars can burn steadily, and that we can stand on this imperfect sphere and gaze up at the stars. So the next time you look at the moon, remember to thank gravity. It molded chaotic cosmic dust into one smooth, rounded planet after another. It shaped our world into what it is today. But in the end, I want to leave you with one question. If gravity can mold planets into spheres, what shape is the universe itself? Is it round? Is it flat? Or is it a shape we cannot even imagine? Scientists have debated this for centuries, and still have no answer. What do you think?